You know that feeling, right? You're using some super powerful AI assistant, you ask it to do something just a little bit different, a little bit new, and it just completely fumbles. It's so frustrating. Well, today we're going to dig into the real reason why that happens. And here's a hint, it has almost nothing to do with how much data the AI has, but everything to do with the kind of data it learned from. All right, so let's get right into this idea of the smart but brittle AI. This concept, it really gets to the very heart of one of the biggest challenges facing AI developers right now. I mean, isn't this the big mystery? You have an AI that can compose music or debug 1,000 lines of code in seconds, but then you ask it to use a new app or combine two simple ideas in a novel way, and poof, it just falls apart. What is going on there? Well, there's a name for this problem. It's called brittleness. It basically means the AI seems incredibly intelligent, incredibly capable, but only inside the very specific box it was trained in. Its skills are fragile. The moment you step outside those boundaries, they can just shatter. So what's the cause? What's making these powerful models so brittle? Well, researchers have zeroed in on the main culprit, and it points to a huge dilemma in how we've been teaching them. And there it is. The real issue isn't a lack of data. We have mountains of data. It's a lack of diversity. For so long, the focus has been on scaling up the sheer volume of information when the actual secret sauce is scaling up the variety of problems, the variety of tools, and the different ways of thinking. See, the old way of making training data was something called a query-first approach. Basically, you just dream up a task like, hey, find the top 3 cited papers from this scientist, and then you try to teach the AI how to do it. The problem, the fatal flaw, is that you might accidentally create a task that's totally impossible to solve with the tools you have. Or, even worse, one where you can't even be sure if the AI got the right answer. It's a huge mess. This diagram from the research paper really paints the picture. If you look at those top and middle sections, you can think of them as the old-school training methods. They either lock the AI into a really narrow set of skills, which means super low diversity, or they create these maybe they're solvable, maybe not tasks, which just grinds the learning process to a halt. And this quote from the paper just nails it. It says, "This creates a fundamental tension, scaling diversity while maintaining data quality." Think about that. How do you create millions of different, unique, and challenging problems for an AI while also making 100% sure that every single one is solvable, that you can check the answer, and that it's actually useful? That's the core challenge. So if that's the problem, what's the fix? Well, let's look at this absolutely brilliant solution that just flips the entire old way of thinking on its head. Okay, this is my absolute favorite way to think about this. The old way was like writing a super complicated recipe for a fancy dish and then just praying you happen to have all the exotic ingredients in your pantry. The new method, which is called Dive, does the complete opposite. It first looks inside the kitchen to see what you actually have, cooks an amazing meal with it, and then it writes down the recipe for the delicious thing it just successfully made. It's a total game changer. And here's the more official breakdown. DIVE stands for diverse, verifiable, and executable, and it's what's called an evidence-first approach. So instead of starting with a hypothetical question, it starts by actually using real tools to get something done. That successful result becomes the evidence, and only then does it work backward to create a training task based on that proven, real-world outcome. The process itself is it's so logical. First, it gathers this huge, diverse collection of resources. We're talking 373 real-world tools, covering everything from finance and biology to medicine. Step 2, it just lets the AI go to town, experimenting with these tools and collecting proof or evidence of what it can successfully do. And finally, based on that success, it creates a task that you know by definition is solvable and rooted in reality. So let's jump back to that diagram really quick. See how Dive fixes the whole thing? If you look at the bottom section, that's the Dive process. It all starts with a real action, a successful use of a tool. Because the starting point is a provable result, it completely sidesteps all the risks of the old methods. It guarantees that every single training example is high quality and, most importantly, solvable. Okay, so this all sounds great in theory, right? But does this clever new method actually perform better? Well, let me tell you, the results are kind of startling. This single chart tells the entire story. That purple line, that's what happens when you train an AI by increasing task diversity with the Dive method. Now look at the blue line. That's the old way, just piling on more and more data of the same type. The result is it's undeniable. Scaling diversity leads to steady, consistent improvement on brand new problems. But scaling quantity, it flatlines almost immediately. And believe it or not, sometimes it even makes the AI worse. And get this, it's not just better, it's way more efficient. The researchers found that this diversity-first approach got better results even when it was using 4 times less data than the old quantity-first method. Work smarter, not harder, right? So how much better are we really talking here? The model trained on this dive data blew the strongest previous model out of the water. It performed, on average, a staggering 68% better across a whole range of really difficult tests. 68%. So let's zoom out a little and wrap this up. What are the big picture implications here? What does this all mean for the future of AI? Well, for one thing, this method isn't just creating simple little math problems. Just look at this example of a task it generated. To solve this, an AI has to use 9 different tools in a 50-step process, juggling author data, citation counts, and journal info. This is the kind of messy, complex, multi-step thinking that real-world problems demand. And it's exactly this kind of training that's going to create the truly capable AI we've been waiting for. So what do you need to remember? Let's boil it down. First, the big takeaway. Smarter, more diverse data is way, way better than just more data. Second, the dive method makes sure that all this smart data is actually grounded in reality, since every task is built on a real success. And finally, this is a huge step toward a future of AI agents that are more adaptable, more reliable, and genuinely more helpful. Which leaves us with one final, really important question to think about. For years, the big race in AI has been about who can collect the most data. But if we now know for a fact that smarter, more diverse data is the real secret, how should that completely change the way we think about building the AIs of tomorrow?